Attempt 4. Come on. Let me live. Let me stream. Let me do the thing, please. It's not even showing up. Fun. Let me live. Let me stream. It's looking better. Let me do the thing, please. It's not even quite a bit better. Fun. Let me live. Let me stream. It's looking better. Let me do the thing, please. All right, we're gonna go with that. Let's try to just run with that, see how it goes. I'm gonna post this link that I just had on my story. Fun. Let me live. It's a little better, a little worse. I need to type them out explicitly, even though that is annoying, just because I've been wasting too much time trying to figure it out in my head. And lastly, I need to make sure I understand the problem statement very well before. So we have puzzle 7, long sum. I have the sum of a batch of numbers. Uses one program block. A block size B0 represents a range of batches of X of length N0. Each element is of length T. Process it B1 less than T elements at a time. Sum of a batch of numbers. So this is my batch. Not sure I understand. Block size B0 represents a range of batches of X of length N0. Each element is of length T. Process it B1 less than T elements at a time. There is no B1, so I'm assuming they mean B0, right? But so it says our output, each element of our output is going to correspond to a sum of within a row. So we have N0 rows of X. I'm assuming that's what these are, right? 1, 1, 1, 2 to 2, 3 to 3. And then we're going to look at a sum along a range of columns J, which is up to T. So I think this is a little bit of an error. This should probably say from J equals 1 to T or something like that, right? But I think it's basically just saying to sum up the rows, but I think the key here is that we need to only do it in batches. So this is probably pretty similar to when we did the vector sum, like the constant add, except that we're going to be doing sums instead of just adding a constant, and then we need to do it in batches, right? If I'm understanding this correctly. Yeah, because the sum spec is kind of ass, but all right. So this is kind of strange though, because it says process B1 less than T. Oh, there is a B1, B0, B1. All right. So first, maybe let's see if we could do it without batching, and then let's see if we could do it into batches, right? So without batching, I think we would just consider each row and add it up, but we would consider it in blocks, right? Maybe I should have like a little whiteboard, right? First of all, I'd like to print some spec of something that's like really obvious, right? So maybe let's do like torch.tensor of 1, 2, 3, 4, and if I'm understanding this correctly, the output should be a vector with 2 columns, and each one should have a single element. It should be the sum of each row, right? So 3 and 7. So let's see what that comes out to. Oh, I need to actually pass it into the function like this. 3, 7. Yeah. So we're just adding each element in the row. So kind of easy to draw out as well. We could probably just say, all right, here's our matrix thingy. It consists of rows of elements. Like this. You get the picture. So what's not clear to me is, so like, it is clear to me that we're going to want to partition this into blocks, right? So I might look at like the sum of these two, and the sum of these two, and then this one, and so on, and write them into my vector. But when I'm doing this batching, it's not clear to me whether it's asking me to do it row by row, or if it's just asking me to sort of do rows like in parallel and then batch the blocks. Like, that's not super clear to me, right? Let's give it a shot, right? First, I'm gonna say, what are my offsets? They're gonna be a range from 0 to B0. And I also want to make sure that I jump ahead B0. So this is going to essentially give me, you know, a little block of the size of my block, and it's also going to put the block in the correct position. Now, I also need to actually get this PID, right? So let's say PID equals TL dot program ID 0. And now we have our offsets, right? I want to load in my block of X by saying TL dot load X. We're also going to make an X mask, right? Because if these offsets go past, I think it should be N1, right? Yep. Yeah, N0 is the number of rows, and 1 is going to be the length of the row, right? So we don't want the offsets to exceed the length of the row. So we'll make sure to use this mask right here. And then when I load in my block, I'll just say X pointer plus offsets. That's what I want to load in. I want to make sure that I use my X mask, right? And this should give me my block of X. Now to calculate my sum, I would just say TL.sum of X block. And I think that's sufficient on its own, actually, right? Then finally, I want to load this in, so I'll say TL.store into my Z pointer with the same offsets, right? And with the same mask. Now there is a problem here, which is that I'm not considering the 2D-ness of it, right? So this is sort of assuming I'm working with a single vector, and I should be thinking about the whole block, right? So this is probably only going to work with the first row, and it's not batched either. But I don't know. I want to run this and sort of see what it says. Maybe it'll kind of do what I predicted, where the first row is correct, or maybe since I'm not batching, the whole thing will kind of break. But let's see what we get out of this. Hey, kind of looks like what I said is correct here. Like we're writing to this first block in the store, right? But yeah, everything is still false. False, 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 right? So, block size B0 represents a range of batches of X of length N0. Block size B0 represents a range of batches of X of length N0. Kind of looks like we're supposed to be thinking of B0 as like Let's see if this has a little bit more like elaboration. No. This is a little confusing how it's presented. Block. Like this picture explanation is not very great. Like if I'm understanding this correctly, what these dots are supposed to mean is essentially that these two are in my block. So maybe my block size would be 2 here, right? and then the length n0 is this length right here. So if each element is of length t, I don't understand where t is coming in here. Maybe it's saying each element this way is length t. We want to process it in blocks, length t at a time. Process it b1 less than t elements at a time. So it sounds like this is where I'm supposed to be doing the loop, right? Is on b1, and then b0 would be my program IDs, right? Process it b1 elements at a time. This implies sequentially, right? So I think my for loop should be this essentially, right? I'm gonna say, I'm still a little confused. What are n0, n1, t? What is t? I think this is like over specified. I remember there were some comments on there being like known errors somewhere. So I'm gonna peek at that real quick, maybe. Maybe let's go to srush. Let's go to this right here. Let's go to this readme. Triton puzzles light. Known issues. Puzzles 11, 12 fail. Compatibility issues. Fix and problem descriptions. Puzzle 6. Puzzle 9. No, so puzzle 7 is fine. I don't know. It's a little confusing, but we're going to try it out. So what I'm going to do is I'm going to say for, what should I call this? I want to use a TL.range, and I want it to be from 0 to t, but I want it to skip steps of B1. That's what we talked about, right? Process it B1 less than t elements at a time. So we could call this my So what would this correspond to? B0 represents a range of batches of x of length n0. So I still think this is n0 and this is n1. I think the confusing thing is that n1 and t are probably the same. Actually, let's try that out. Let's print each of these. Let's print let's print all of these. Let's see what happens. 432 200. It never says what N1 is in the problem description. I wonder if anyone said that in the Discord too. I might look there real quick. Oh, that's from the project. I'll look at that later. I'm gonna go to Triton puzzles. It does look like they might have said something in here about it, but we'll see. In Triton puzzles, we're gonna look for 7. Why are people acting like this is clearly specified? Yo. What the hell, Daniel? Well, I think I'm gonna abandon the batching a bit and just see if I could think of a solution that uses one thread on its own and kind of see if that does like a memory error or something. I'm still a little confused, right? So we have our batches. So I'm gonna say PID equals TL.program ID 0. We already had that, right? And basically, what this tells me is I still want these offsets, right? But I think the way I should be thinking about this is that, I think this is also correct, right? The offset's less than N1. But then the thing I'm loading is a bit wrong, right? Because this should actually be like a whole, I'm not just doing a piece of a vector, I'm doing a piece of a whole matrix, right? So this is kind of doing it in like a vector style, and I want the matrix style. Maybe that's what N1 is supposed to be. So like right here, right, this is my I offsets, right? But if I'm thinking about it, what do I really want for my block offsets? I want I offsets times actually these are my J offsets, right? These are my columns. But really what I want is my I offsets times rows plus my J offsets, right? So I want basically what I'd want to say is, like, if I was loading this block, right, I'd want to say these are columns 1 and 2, and then this is rows 0, 1, 2. So I'd want a vector that has 0, 1, and 2, and then to each of those I would add 1 and 2, and that would sort of give me this 2D block, right? So my I offsets would be what would it be? It would be and 0. Like this, right? And then I offsets times, what do I want? Times so I'd want it to look like, so for this, for example, I don't want it to be like 1, 2, what would I want it to be? This would be 0, 1, 2, 3, 4, 5, 6, 7, 8. So I want 0, 1, 2, I want 1, 2, 4, 5, 7, 8. Hmm. One, 4, 7. What's that jump? That's plus 3 each time. 0, 3, 6. Plus 1, 1, 1. Plus 2, 2, 2. Yeah. I want to multiply this by n1. Because that's the length of this row, hopefully. This problem description's a little confusing. So actually I wouldn't put that there, I'd put that here. And then lastly, what do I want here? I want my x mask. So I'm going to say the I mask is that the I offsets needs to be less than n0, which we already know it is by definition, right? I'm kind of just doing this because I have a feeling I'm going to need to change it in the future. And then for the j offsets, I need them to be less than n1, which is this, right? So rows need to be less than this, columns need to be less than this. And then for my ij mask, I need I offsets and I need I mask and j mask. And I need these to be expanded. How do I need them to be expanded? I need it to be these need to be expanded too. So I need this to be a column vector, right? So I need to say keep each row but add a new column. And then I need this to be a row vector. I need this to be keep each, add a new axis here and keep each row. I think we'll do the same thing for the masks. Like this. And then when we load in our X block, we're doing it like this, right? We use our ij mask and we're gonna use our block offsets. And this is probably going to be too big, which is probably why they're saying we need to do it in batches. But let's call our sum this, and let's do it along axis 1. And then let's store our block offsets, our sum, with the ij mask like this. And so I have a feeling this is going to kind of get like a memory overload error or something like that, but I think this is the correct logic, right? Let's see. A range's arguments must be of type TL.constexpr. Hmm. So now that I've fleshed out most of this logic, let's try breaking this logic into blocks. And we'll do it across this, right? Because this one already has a const x per argument. We need to make this a const x per argument right here. So what I'm going to do is I'm going to say for block in TL.range 0 to TE1, maybe. Let's put all this in, right? And let's make this B1. And we're also going to multiply this by block times B1, right? And so I think if T and N1 are the same, that's not really clear to me right now. I mean, they're not the same, right? But like I'm having a hard time understanding what's actually the input to this. So maybe I need to test it on some different inputs. But this should sort of split up what we did into smaller blocks. Cannot broadcast. Rank mismatch. 32, 32, 1. Head equals TL.program ID 0. Yep, for each of these blocks. I need to see this work for like let's try this, right? Let's say x equals torch dot tensor of what? Let's make it 1, 2, 3, 4, and 2, no, like 17, 1, 5, 7, 6, or something. And then lastly, let's make this 11, 11, 13, 14, whatever, who cares, right? This is our x, and so our z is just going to be a torch.zeros of what? It's going to be x dot shape 0. So let's print x and z maybe, right? This looks right. So now I'm gonna pass these into my sum kernel. It's gonna have x and it's gonna have z. And then see like what are these n0, n1, I'm not sure. So for 432, 200, 132. What is that? Let's try like 2 and 3 for B0 and B1. And let's try Is there a third dimension I'm not understanding? We have 4, 32, 200. Because this is the block. What is this? I don't know. Let's just say 1 and 1 here. I don't think that's going to work, though. Cannot call that Triton.jit outside of the scope of a kernel. Oh yes, I need to, hold on. There's a thing I need to do. This, I need to do launch grid, right? So let's say some kernel of I don't know, 1 1 or something. Oh, how? Let's look over at the demo again. I have 1 1 1 here. Does that work? Let's just ask ChatGPT on this one, actually. Ignore that part. N0, N1 is x dot shape. Okay. So that helps a little bit. And this should be N0 because we're only using one program blocks, right? Our launch grid is going to be one-dimensional. I have a feeling this is just messing with, but it's because of the other, it's because of the other thing, right? I'm still a little confused on like what is this is the block size in the n1 dimension. B0 represents a range of batches of X of length n0. Okay. What does B1 represent? It seems like it should just be like pieces of columns, right? Each element is of length t. So why are t and n1 not the same? I have a 4 by 32. No, I have a 4 by 200. What is 32? It's not the X shape, right? Four by 200 sounds more correct. Then what is this? You notice N1 and B1 are the same? I wonder if that's a coincidence. B0 is 1, it's saying just do it one row at a time or whatever, right? But what is... I think N1 is supposed to be how many columns in a row we're doing together. And that's why it's the same as B1. And I think they kind of messed up the specification a bit. So this corresponds to we don't need to compute that every time, right? We know which rows we're summing. It's these rows. But so this should be... These are swapped right now. They're kind of messed up, right? This should be B0. That's what B0 was, right? B0 represents a range of batches of X of length N0. So this should be B0 and this should be B1, like this. I had this part correct. Still not clear to me that this is being written correctly, though. Yeah, so instead of this being block, this should be PID, and this should be block right here. Rank mismatch 1, 132. Where is that coming from? Is that here? Is that this? Oh, I see, because this sum, this block is still could be 1D, right? No. What? Maybe? Yeah, we have 132, 132, 132, like that. Input, axis. Yep, and then, I see. We don't use our IJ mask. IJ mask and block offsets is the wrong thing to use because they're 2D, right? They were what I was using for my block mask and my block offsets and my block mask. When I do the sum, I want to collapse along the columns, so I'll have a 1D version, right? So what I should be using here is my my I offsets, right? I want to write to each row, and what I write to each row should be the I mask. One problem I'm seeing here is that this is gonna overwrite past values, so I need to like accumulate, right? How do I accumulate properly though? Let's see if I'm even doing the reads and writes correctly though. That looks horrible. Okay, so first like obvious fix to me to make is when I accumulate here, I need to make sure I like maybe right here what I should be doing is I should say z block equals tl dot load z pointer plus I offset like this with my I mask, right? Then I'll say this is my sum down here, and then I'll say z block plus sum like that, right? And so then each time right here I'll be putting my z block right back, but with my new sum on there, right? So let's print z block, and let's print z block again. We could say, I don't know, before and after, right? Just like this. Try that out. So like right here I have before 0.2, after is minus 0.57, before is minus 0.56405, which looks correct because of this, right? So we're accumulating on each one here. Except these zeros don't look great. In my store, looks like a lot of stuff isn't getting stored properly. So let's see. When I'm loading my Z block, I'm using my I offsets, which is these. This I mask doesn't need to get recomputed each time either, so I'm gonna move that over here. So I have N0, N1, B0, B1, B2. No. N0, N1, T is this, and then I have B0 and B1. Try printing my block offsets and seeing what they look like, right? So I'm seeing 0 to 31 and then 1024 to 1055. Does that sound correct? This is because I'm multiplying by 200. So maybe this N1 should be a B1. What does that give me? 0 to 31, so I'll get my 1024. Where's 1024 coming from? Because the next one should just be 32, right? I don't know why it would be, unless this was just a whole different thread. That might be what's happening. Yeah, let's put the PID in the block as well. So like right here I have 0, 0, 0, 32. Where's 1024 coming from? Maybe I could print I offsets times N1. Fuck. I didn't mean to save. 0. Where is this 1024 coming from? I'm so confused on where some of this is coming from. This is J. Why does the J look like this? Block times B1. So let's print block in B1. Okay, we have 0, 32, 0, 1, 2, 3. This makes sense. No, it doesn't. We have 0, 0, 0, 1. This makes sense. Okay, I have 32 times 32. Here we go. I don't want 32 times 32. What I want is 1 times 32, right? So I need, like, the block ID is block divided by B1, like that. So there should be a tl.cdiv, I think, actually. And then let's see if this stuff starts making a little more sense. So I have 0, 0, 0, 1, 2, 3. This should be block ID right here. And this should also be block ID. This should also be block ID. Like this. Let's try it again. So we have 0, 0. This makes sense. Now we have 1, 32, 32 to 60. Yep. So this is what I'm looking for right here. And this might not be correct, but it's a lot closer to what I wanted. Right. So let's continue from here. Let's get rid of this and get rid of this. And let's look at the X block, that shape again, and our sum and all of this. 1 by 32. See, this 0 each time still isn't great. I don't know what that means, right? Maybe let's print our just actual X block. And let's also do our block offsets. and see if that gives us something a little bit more interpretable. So for the first 32 indices, we get these numbers. They sum up to this. That looks good. Kind of weird this already has a number in it. Maybe we should be zeroing this out first. But I'll deal with that in a second. Why are these numbers all 0? That is strange. Right, because we have a 4 by 200 matrix, so this should be fine. I wonder what's going wrong there. Let's look at our mask and make sure it's not doing any weirdness. So we've got all true, and we've got all false. That looks like a big problem, right? So where is all false coming from? Let's print our I mask and print our J mask and see what's going on there. So for my I mask, I have the single true, which makes sense, and that's not going to change throughout the loop because we defined it outside of our loop. But for the J mask, it looks like I have all true for the first one and all false for the second one, which sounds just not correct. Right? Maybe instead of N1, this should be a T. Let's try that out. Let's see what happens there. Now I have truths all the way until it looks like here they get interrupted at false. This is behavior we're looking for. That looks better. And maybe it'll actually show up in the images, right? Not quite. But we're getting closer. So one thing I want to fix, right, is Z block right here. Z block should be getting stored 0. And then let's get rid of some of this stuff. Yeah, let's try that. So right here, I've got my X block, sums up to minus 0.7. We started 0. We add this, that looks correct. We add this in, yeah, so we're getting this sort of cumulative sum as we go. That looks correct. And then that still looks good right here. This part's a little concerning, right? Isn't that the same number? Minus 0.778317. Minus 0.778317. Right at right on this new row, right? Because let's do what do we want to do here? We want to do PID, right? What's wrong with that? Oh, I didn't put an underscore. So right here, we're summing up all of the stuff in the first row, the 0th row. And when we switch to row 1, this number looks the same. Well, actually, yeah, this number looks the same. there should be there should be a plus, not a multiply sign. Let's try that out. So let's see if that improved our access pattern, right? Oh, hey, look, yours has the correct sum for the first row, but the other rows look like they're not correct. Progress. And if we look here, right, when we switch to row 1, it looks like this number is different. So we're getting closer. So now I wonder if there's just like a logic error somewhere or something. I'm gonna take a minute, because sometimes if you just keep grinding, you get a little lost. By the way, if it's not clear what I did here with the C div, basically the premise is that I'm trying to iterate over each of the columns in blocks of size B1, right? But when I get to a certain block, say the third block, what the value that block has is actually going to be the sum of the sizes of each block, right? I start at 0, and then if the block is 32, then the next value of block will be 32, and then 64, and then 96, right? But when I'm doing this offset work, I want to know what index block I'm on, right? I want to know, am I on block 0, block 1, block 2? So I need to divide by my block size, B1, to get that back, right? And the reason we do the ceiling division is because sometimes with these masks, right, or just like think about like T might not be a multiple of 32. Say T is 100. Well, that's not 100 isn't a great example, right? The premise is to do with if we have an overhanging block, we want to make sure we include the beginning of the block, right, and not have some remainder. It actually might not be necessary here though because of the construct we're using, the range, but it also doesn't hurt. Okay, let's come back to this. I wonder why the first row is coming out right, but then the other ones aren't. Let's see. Let's just go line by line. We have the correct program ID. We only have one axis in our launch grid. For I offsets, we don't have a stupid error here with multiply sign, right? We're loading in a block, and we're loading in the PID, the block corresponding to the PID. And for I mask, we're making sure to stay within our rows. Here, I'm zeroing out each element in our Z block. That looks correct to me, right? I could sort of say print tl.load Z pointer plus I offsets with our I mask. And this should just be a vector of zeros, right? Yep. Right here, 0. For each block in range 0 to t of B, subsize B1, we're gonna get our block ID just like this. Our J offsets are gonna be is gonna be just like the I offsets, B1, plus block ID times B1. For block offsets, we're going to, this part might be a little messed up. Right, what is that? I have N0, N1, 32 right here versus, well, what else would it be? It'd either be T. Let's try putting T there. It's supposed to be the all of the elements in an entire row, which we saw before we had to fix with a T. Hey, correct. We did it. Let's get rid of these print statements and stuff, clean it up a bit. And I still think we should look at it a little closer, right? Because it's not clear to me that we actually optimized it the way we should in terms of fusing operations and stuff, right? So one thing right here, I won't write the sum to high bandwidth memory. I'll just do it inline, and I'll sort of hope that Triton fixes that, like optimizes that. Let's see if these write patterns look better. Yeah, they do. But we're still doing a lot of loads and stores, right? Like, there's probably a better way to do this. Let me think about it for a little bit. But I'm pretty happy about that. We got one. It's probably time for me to go to sleep after this. So how many operations are we doing here, right? I'm doing a store. I'm doing a load. I'm doing a load. I'm doing a store. This only happens once per PID, but this is going to happen a number of times for each PID. So it's sort of like 1 plus 3n operations, right? What I'm sort of wondering here is if we need to do this, right? Like, is each one necessary? This one's definitely necessary. Let's see. I have to load in X to achieve my sum. I have to load in Z. Do I need to load in Z? Yeah, I have to load I have to load in Z to be able to add my values of X to it, and I have to write it back in. I don't think I can do this faster. I think if we wanted to do this faster, we'd have to I think that's good. I'm pretty happy with that. Let's try adding this to my Git. Oh, actually, let's see what someone else did in the Discord. Remember, we saw a solution, we skipped past it, we didn't want to, like, cheat. right? Or actually, better way to do that would just be look over here, right? Let's see what the reference solution is. Looks like they do the same thing right here. Their loop is quite a bit smaller though. Ah, see? I see here. I see what they're doing. So I should be a bit more mindful of this, right? This range, even though it's not the Python range, and so there's things that go into it like number of stages that you use and stuff like that, right? Like I think there's a parameter here called num stages, if I'm remembering correctly. I don't want to mess up this configuration, right? But it's still going to all be happening in this single thread, which means that we can, excuse me, we can prevent going all the way back to main memory and do some of this work right here in the SRAM, right? So actually, probably what I should be doing right here is I should be, instead of doing a store here, I should just be creating a vector, right? I should just say, how do you create a new vector in Triton? I'm not sure if I've done that before. But so basically what I should be doing is create new vector in SRAM, right? So I don't need to travel to main memory to load it in. And then when I'm doing my accumulation, I should do the accumulation on this vector in SRAM so that I don't have to keep loading and storing back and forth, right? And then once I've finally accumulated my sum, I should write it into SRAM. So really we can eliminate a lot of these operations that we're looking at, right? So let's see if I can create this new vector. I don't really remember what the actual, is it like to use tensor or like that? Let's see. N-dimensional array of values. Yeah, I'm gonna assume it's kind of similar to PyTorch, right? So we'd want to say this needs to be size what? B0, because this is our Z block. And it needs to be actually it's not even, they haven't even talked about types here at all either, right? 32? Yeah. I think so, right? Float 32? Yep. And I'm gonna print this real quick. Does it just automatically initialize it to zeros? Oh. How about we try 0 times B0, like that. What? Let's look over here what they do here. TL that zeros, oh, well, okay. TL that zeros, tuple of ints is for the shape, so we got this right here, right? And our D type should be this. So now over here, excuse me, we should be loading this in, and then instead of doing this store operation, we can say Z block plus equals sum, like this, right? And now what have we done? We've gotten rid of the one read operation here and made it 0 read operations. And in our block, which I sort of just said is going to run n times, we're only doing one load operation. It looks like not any others, right? We got rid of the load operation for the Z block because we're doing it in SRAM. We're keeping it in SRAM. And we got rid of the write operation of the Z block back to SRAM. And so to make up for that, right, we need to finally write at the end. We need to say tl.store z pointer plus I offsets with the I mask. We need to write in our Z block, right? Does this still work? Yeah, this still works, right? But so what we did here was fusion, right? We fused some operations to, well, I don't know if we should say fusion, right? But we essentially, we did some accumulation inside of this thread so that we could eliminate a lot of operations, right? We made our accumulation in SRAM. We accumulated in SRAM. We only loaded for each iteration and then stored once we accumulated. So I'm pretty happy with this. I'm gonna put this on my GitHub, and I think I'll leave it at that. I don't want to do another one. It's almost 1 a.m. So let's try running this on my friend's actual GPU. So this should be this. Then I'll say Python puzzles.py. I think the flag was -a. And this passed puzzle 7, which is the one we just did, right? Yep. So cool. I'm gonna add this. I'm gonna say, why is this yellow? I don't know. Git status. Git add puzzles.py. Okay. Nice. Thanks for watching, y'all. Next time we'll do puzzle 8, which is what? Long softmax. So this will be where we get some fusion.